So with similar, your angles are all the same, but your side lengths are in proportion. So you guys know scale models? When you build a scale model of something, like they'll do, like an architect will do a scale model of a building, or they make scale model cars and things like that. And basically it's like somebody took the actual car or building and then shot it with a shrink ray, shrunk it down, but all of the proportions are the same. You wouldn't have like a car with bigger wheels than on a normal car. It's proportional. So what you have with a similar polygon, so angle A and angle P are corresponding, so they'll be the same. Okay, so angle A would be congruent to angle B, or P. Why not working? And then angle B would have to be congruent to angle Q. Angle C would have to be congruent to angle R. Angle S has to be congruent to angle D. And angle E has to be congruent to angle T. Okay, so that's the first part. All your angles are the same. And then if we look at the side lengths, okay, what you get mathematically is the ratios are the same. So the side AB over the side PQ would be the same ratio as BC over QR, which would be the same ratio as CD over RS, which would be the same as DE over ST, and that would be the same as EA over TP. Now, number-wise, okay, let's say I just assign some lengths. We'll say this length is 5, 6, 7, 8, and 9. I'm just randomly assigning lengths, okay? Well, oh, I went the wrong way. That should be bigger numbers. Okay. Each of these ratios will be the same. So if I put 10 over 5, that's AB over PQ, that's 2. And then if I put BC over QR, I get 12 over 6. And if I put CD over RS, I get 14 over 7, and 16 over 8, and 18 over 9. 10 over 5 is 2, 12 over 6 is 2, 14 over 7 is 2, 16 over 8 is 2, and 18 over 9 is 2. So you can see the ratios are all the same. Even though they look different, they equal the same number. So you have to have both of these situations in order to be similar. Okay. So let's look at the terminology first. If I say triangle GFH, and then I have triangle LJK. Now when we used congruent, we had like an equal sign with a squiggle on top. Similar is just the squiggle. So this actually means similar. Okay, so I'm going to say that triangle GFH is similar to triangle LKJ. Make my L cursive because then it's easier to tell it's an L. Okay, we want to write the statements. Oops. Okay, we want to write the proportions for the sides. Sorry, that looks horrible. So the congruent angles, if they're similar, they go in order. So G is going to be congruent to L, F is going to be congruent to J, H is going to be congruent to K. So we'll write that down. Okay, so those will be pretty easy because you just go in the same order as the triangles are written. Okay. Now the proportions of the sides, if we look, we have G congruent to L, and I had put those as right angles. So I can go clockwise around the triangle. So I'm going to move this direction, like that. I'll do the same thing over here. I'm going to move clockwise around the triangle. So I'm going to have GF is my first side. And I'm going to start with the same angle that's congruent, so L, and I'm going to go LJ. And that is going to be equal to FH, JK, and then HG, KL. And if you look, the triangle was GFH. I have G, F, H, and then L, J, K. So that I know I did them in the right order. Does that make sense? Okay, now, these ratios are all the same, correct? And these are the scale factor. Okay, when you talk about an item like a scale model or items to be to scale, they've been either enlarged or they've been shrunk by a specific number. Now that number can be a fraction or a decimal or a whole number. That doesn't matter. Like I can shrink something by 0.23 if I want to. Or I can enlarge something by like 7.9. But the ratio gives us the scale factor, and this is the number of the enlargement, or the size change. I don't want to say necessarily enlargement, but the size change. So if I know two sides, so if I have this side here and I have this side here, I can figure out the scale factor, and that lets me find missing information if I don't have it. So the scale factor on this particular triangle, if that's 8 and that's 4, I'd have 8 over 4, so my scale factor would be 2. So that would tell me that this triangle is 2 times the size of that triangle. Or if you go the other direction, this triangle is 1/2 the size of this triangle. Yeah, or if it's not something even, like let's say I have 7 over 10, that could be the scale factor. So it can be a fraction, or it can be a whole number. It can be a decimal. I could actually divide that and give you the decimal if you wanted, if that made more sense. And we use the scale factor to find the missing sides, okay? Okay, so to check to see if shapes are similar, first you would want to look at their angles. Well, we're looking at rectangles right now, so in a rectangle, all angles are 90 degrees, so they're all congruent, no problem. Correct? Yeah. Yeah, so we know that those are congruent. We don't have to worry about the angles on the rectangles. So then the next thing we need to do is we need to see if the scale factor is the same. All right, so what we look at is I have that side BC corresponds to side FG and side KL here. And then side DC corresponds to HG and LM. Okay, so corresponding sides are going to be in the same position. So what I do is I set up oops, I'm using the wrong pen, sorry. It's ghost writing. We're going to set up proportions and we're going to see if they're equal. 8 over 12 should be the same as 10 over 14 if these are proportional, if they're similar. So I check that. I go 8 over 12 and 12 over 14. And sometimes it's really easy to see and sometimes it's not. So what I usually do is I just recommend always cross multiplying and then you can always tell. So I'll have 8 times 14 and 12 times 12. 8 times 14 is 112. 12 times 12 is 144. These are not equal. Because those are not equal, A, B, C, D is not similar. Well, that kind of looks like an X, doesn't it? Not similar to E, F, G, H. Doesn't work. So then we'll try the next two. So I'll have 8 over 12 again, and then 10 over 15. And I'll cross multiply. And I get 8 times 15 and 12 times 10. 8 times 15 is 120. 12 times 10 is 120. These are equal. So rectangle ABCD is similar to JKLM. Yes, thank you. Good catch. That should be 10, so this should be 10, so that should be 120. Let me fix that. Thank you for catching that. Now the other way to do this, I could take these fractions, 8 over 12 and 10 over 14, and reduce them. And I get 4 over 6, which is 2 over 3. And 10 over 14 gives me 5 over 7, and those are not equal. So then these are not equal. And that works okay if you've got like these nice small numbers. But if you've got decimals in there, or if you've got large numbers, it can be very time consuming to reduce them down. So that cross multiplication will always work no matter what the numbers you're using are. When we have something like this where it's not like a rectangle, where every angle is 90 degrees, we have to make sure that the angles are congruent first. Okay, well Q is congruent to S. So I have Q congruent to S and N congruent to R. And because it's a triangle, if these two angles are the same, then P and T are the same. Right? Because triangles always add up to 180, so if 2 angles in one are the same as 2 in the other, then the thirds are the same. So angle P is congruent to angle T. So I've got the angles. We're good there. Now I need to look at the sides. N and Q are the same angles as R and S. So that tells me that side RS and NQ should form a ratio. So I want RS And I need that to be equal to QP, which is the 2 and the none, to be the same as the other 2 and none. So I need QP and ST to form a ratio, and then PN and TR. Okay, so QN is 12.5, and QRS is 10. QP is 11.5, and ST is 9.2, and then PN is 15, and TR is 12. So this is what I need in order for these to be similar. So in order to check this, I can either try to reduce them all down to something, but there's decimals in there, and I don't like reducing fractions with decimals in it. It's just not fun for me. So what I'm going to do is I'm going to actually do 2 sets of cross multiplication. I'm going to cross multiply here, and I'm going to cross multiply here. These will be equal, and these will be equal if this is truly similar triangles and everything's in proportion. So I'm going to get 12.5 times 9.2 and 10 times 11.5. Yeah. And so I need to multiply that 12.5 times 9.2, and that gives me 115. And this gives me 115. So no, you have to just do 2 separate cross multiplications. You could do, like, say, the first and the third if you wanted, with the second and the third, but it's usually just easier to do these 2 and then these 2. And then I'll do the second one, so I have 11.5 times 12 and 9.2 times 15. You can start in any order. You just want to make sure that you keep, so say I'm using the angles as my sort of basis of where I'm going. So I did N and Q first because that's between the 2 angles that were marked. So then I knew to use this side and they went together. And then I did the 2 angle with no angle or no marking. And then I did the no marking with the single marking. But it doesn't really matter what order you go in. Just keep them, they have to match. So I couldn't put, say, this number QP with SR because those aren't corresponding sides. The corresponding sides have to be between the same angles. Okay, so what I got, now I got 115 here and 138 here. All right, but these were equal and these were equal. This first set being equal means that those are equal. This second set being equal means that these are equal. So if this equals this and this equals this, that means all 3 of them are equal. So yes, they are similar. So I may not get the same number here as long as they're equal. They have to both be equal when you do that. Does that make sense? Okay, so I'm going to find the missing sides. I'm going to find x, and I'm going to find y, 3y minus 1. I'm going to find this side here. The first thing I want to do is mark the angles, because that makes finding the corresponding sides easier. I have ACDF is similar to VWYZ. This means that A and V are congruent. C and W are congruent, D and Y, F and Z. So I'm going to mark that. A is the same as V. C is the same as W. D is the same as Y. and F is the same as Z. What that tells me is that AC is going to be similar to VW. CD is going to be similar to WY. DF is going to be YZ, and FA will be ZV. So that's how I'll know similar. I'll be between the same marked angles. Does that make sense? Okay. Now, that means that this 9 is going to correspond to this 6. This 12 is going to correspond to the 3y minus 1. And the x is going to correspond to the 10. Okay. So that was step 2. I marked the corresponding sides. Okay, so I know what goes with what. Okay, the third step is to set up the proportions. Now it doesn't matter which one you put on top. Like I'm using 9 and 6. I can put 9 on top of 6, or I can put 6 on top of 9. Okay. What does matter is if you put the big one on top in the first fraction, you have to put the big one on top in the second fraction. If you put the small one on top, the small one has to be on top. You have to be the same. So you're going to either do big over small equal to big over small, or you can do small over big equal to small over big. Okay, what you cannot do is do a big, small, small, big. Does that make sense? So whichever shape you put on top stays on top, whether it's the big one or the small one. Okay, so I like to put the littler number on top just because to me that looks prettier, doesn't make a difference at all. So I'm going to put 6 over 9. And I'm going to solve for x first, so I'm going to do 10 over x. Small over big, small over big. Step 4 is to cross multiply and solve. So I'm going to cross multiply, which will give me 6x is equal to 9 times 10, or 6x is equal to 90. That's a 6, sorry. Divide both sides by 6. Is it 15? Cool. Okay, so this missing side is 15. Then I'll set up my next proportion, and I have the 6 and 9 again. I'm still going to use that same initial one that I started with. Only this time it's going to be set up next to 3y minus 1 over 12. Cross multiply, and you get 9 times 3y minus 1 is equal to 6 times 12. I'm going to distribute that 9, and I'm going to get 27y minus 9 is equal to 72. Add 9 to both sides, and I'm going to move it. And I get 27y is equal to 81. Divide by 27, and then you get y is 3. Okay, but I didn't want to know what y was. I want to know this whole side. Yeah, x is 15. Here? This is the first problem, and this is a different problem. So this one I was solving for 15, and this one I'm trying to find the 3y minus 1. This one's the blue, and this one's the red. Okay, but again, I don't want to know what y is. I want to know what this side is. So I need to plug that in. So I take 3y minus 1. Y is 3. 9 minus 1 is 8. So this side here would be 8. Same scale factor between the length of the individual sides and the whole perimeter. So if you were asked, let's say you had one pentagon, and you knew all the sides on that one pentagon, and so you were asked to find the perimeter of a similar pentagon, you wouldn't have to find all of the individual sides. You just find the scale factor between two sides, and then the perimeter of the first one, then you can find the perimeter of the second without having to find like all 5 sides, which is nice. So what you have is, if you have a shape, let's do just a general quadrilateral. And those aren't at all similar, but pretend that they are. Okay, you'd have all the sides in proportion, but that's also equal to all the sides added together. These are the perimeters. So what I have is I have two similar pentagons, and I'm trying to find the perimeter of RQPST. Now, I have enough information to find the perimeter of the first one, but not enough information to find the perimeter of the second. If this side is 8, this side is also 8, because they're marked single line. And this one's 4, that makes this one also 4. So the perimeter of this one would be 8 plus 8 plus 4 plus 6 plus 4. So 16 and 10, 26 and 4 would be 30. That would be the perimeter of the large one. That doesn't tell me anything about the perimeter of the small one. Now, because they're similar, I could go through and find all of the sides and then add them all up. But it's easier to just find the scale factor and then use the perimeter of the first one to find the perimeter of the second one. So what I'm going to do is I'm going to mark that A is the same as R, B is the same as Q, C is the same as P, and D is the same as S. And then by not marking it, E and T will be the same. I have RT. RT corresponds to AE. So I can put those in a proportion. And I know that this side is 8, AB. I can call this side X and say that they go together. And so I can put X over 8. I'll cross multiply. Actually, I don't even have to do that. I'm totally doing too much work. Sorry, guys. Get rid of all this. We don't need to do that. This is my scale factor. 3/4. One side's 3, the other side's 4. I don't need to find other missing sides, right? I just need to find the perimeter. Well, I have the perimeter of the 30. And I don't know the perimeter of the small one. And that's the one I'm looking for. So I'm going to cross multiply. And I'm going to get 4x is equal to 90. Divide both sides by 4. And I'm going to get that the perimeter of the second figure is 22.5.